Yes, Nana. Good evening to all of you. Now today discuss about some more important organic chemistry questions. As in the last class, we discuss about some questions regarding the organic chemistry. Continuation of that. Now see the question given like this. Nana, listen to questions carefully regarding the concept of this organic chemistry. Right, Nana? How the questions are given here. Check the questions carefully what I am saying. See, name the products ABC formed. See the questions carefully. Name the products ABC formed. Wait for 1 second. Where the pen is there? Wait for 1 second now. Yes. So name the products ABC formed in the given following reaction. Ethylene. What is ethylene? CH2 double bond CH2 is called ethylene. So addition of the Br2. Yes, you are very well known. Luminar heating you get what? Br plus, Br minus. Br plus is called electrophile. Br minus is called nucleophile. Because of heating you get Br plus and Br minus. Now here what happens? So one of the pi bond is shifted like this and you get negative charge here and you get positive charge here. You ask the question, why is a pi bond very long? Because pi bond is a weak bond. Yeah, no, no. Kevin creation, yeah. Understood what I am saying? Yes. Now Br plus attack on the C minus and Br minus attack on the CH2 plus and you get what student? You get CH2 Br single bond CH2 Br. Understood? This is called for in organic chemistry writing of the product name is very important. You get 1,2-dibromoethane. Tell me what you get student? 1,2-dibromoethane, right? Now that is the A. So 1,2-dibromoethane is the A. To that adding of what? Alcoholic KOH. What is alcoholic KOH? That means KOH dissolved in the alcohol. What I am saying? KOH is dissolved in the alcohol. What is the purpose of alcoholic KOH? Is helping for what? Helping for removal of H atom and bromine atom. Helping for what student? Removal of the H atom and bromine atom. Simple logic, no confusion. Now one of the hydrogen leave out as H plus. The H plus is removed by the strong basic nature of the H minus. Now the Br is leave out in the form of a Br minus. Now loss of what? Loss of the Kbr plus H2O. So from that what you got? From that you got here CH2, okay, CH Br double bond you get CH2. Again by adding of the alkyl, because alkyl KOH 2 moles is using. You ask a question, why sir 2 moles of the alkyl KOH is using? Because here 2 bromine atoms are there. What I am saying, 2 bromine atoms are there, that's why. So again by adding of what? Alcoholic KOH. Simple logic. You ask a question, why sir you add 2 moles of the alkyl KOH means because 2 bromine atoms are there. So what is the purpose of the alkyl KOH? Help in the removal of what? Hydrogen atom in the form of H plus. Understood? So Br is given out as what? Br is given out as a Br minus. Right? In the form of what? In the form of the Kbr plus what? In the form of H2. Now from that what you got? You got CH triple bond CH and you get acetylene gas forms. Tell me what is forming? Acetylene gas is forming. Understood what I am saying student? Yes, simple logic, no confusion. So this is acetylene gas. Now this is the B. Now B forming is what? The B forming is acetylene gas. What is acetylene? Ethane gas. Now to this ethane gas, again addition of the Br2. Here because of 2 pi bonds are there, adding of what? 2 moles of the Br2. So by adding of the 2 moles of the Br2, what you get? We get CH Br and single bond you get what? CH Br and your answer is what? And your answer is tetrabromoethane. Tell me students what is the answer? Tetrabromoethane. Simple explanation, no confusion of explanation. So now here simple reaction. So A is what? A is 1,2-dibromoethane. Again heat with 2 moles of the alkalic KOH. If you use the 2 moles of the alkalic KOH and you get B, The B is what you form, the B forms is what? The B forms acetylene gas. Understood? Now to that acetylene gas, adding up 2 moles of the Br2 and you get tetrabromoethane is forming. What is forming? Tetrabromoethane. Simple logic, no confusion. Is one of nice question there in the previous paper. All the questions now I explained belongs to the previous paper questions. And see next one. What is substitution reaction? Explain any two substitution reactions of the benzene. Now see the simple statement. The simple statement is what? Substitution reaction. Simple statement I explained. Substitution reaction means the reaction in which one of the atom replaced one of the atom of the molecule. The writing of the statement is very, very important. While you write the statement, now the writing is very, very important. Substitution reaction means the reaction in which one of the atom of the molecule substituted by the reagent. Substituted by the reagent forms a product. Forms a what? Forms a product. That is the meaning of what? That is the meaning of the substitution reaction. Next, what I am asking, explain any two substitution reactions of the benzene. Regarding the two substitution reactions of the benzene, first we discuss about what? Easy. Halogenation of the benzene. So what's the meaning of the halogenation of the benzene liquid? Now regarding the halogenation of the benzene liquid, we take the example of this benzene. Yes. So in the benzene C6H6, its formula, heat with what? Heat with the halogen. What is halogen? You write on heating you get X plus, X minus. In the presence of what? Anhydrous AlX3. What the catalyst is, student? Anhydrous AlX3. Now one of the hydrogen atom, simple explanation, no confusion. So one of the hydrogen atom replaced by what? One of the hydrogen atom replaced by H plus ion. H plus ion react with what? This X minus ions loss of HX. Now here sigma bond is there. Sigma bond is what? Negative charge. Now X plus attack on the sigma bond has a negative charge. And you get what? And you get halobenzene. Simple explanation, you get C6H5OX. That's the answer you got. Understood? One of the example of halogenation. Halogenation of the benzene. And write the second substitution reaction. The second substitution reaction we take methylation of the benzene. What I am writing? Methylation of the benzene. Now regarding the methylation of the benzene, so what you write? Say for example, benzene. The benzene formula is what? C6H6 is a benzene liquid. Now do this benzene liquid, adding of what? Adding of the methyl fluoride. So what the catalyst is used? The catalyst is anhydrous AlCl3 is the catalyst, just on heating. Now what happens? So one of the sigma bond is moving towards the chlorine side. Chlorine gets negative charge and you get CH3 plus. Now simple logic. The hydrogen atom replaced by what? Removed as a H plus ion. The explanation is not so much difficult. Explanation is very easy, right? So the removal of the H atom as H plus. Now what is the electrophile? Electrophile is CH3 plus. Attack on the sigma bond. The sigma bond have a negative charge. Now you get methyl benzene. Now this methyl benzene is called what? The methyl benzene is called toluene. Tell me what is forming? Toluene is forming. Simple logic, no confusion. Understood what I am saying? Simple explanation, no confusion of this explanation, right? Yeah. So this is completed. And go to the next question. So what is the next question given? So which type of the compounds react with the ozone? Explain with one example. Simple logic, Nana. See, the hydrocarbons, tell me what I am saying. The hydrocarbons with unsaturated nature. Understood what I am saying? The hydrocarbons with the unsaturated nature of the molecules. Unsaturated nature of the molecules react with ozone. Tell me what I am saying. The hydrocarbons with unsaturated nature of the molecules react with what? React with the ozone gas. Understood what I am saying? Yes. Why? Because the ozone gas easily attack on the double bond. In the double bond, the pi bond itself is weak bond. Kevin creation. Understood what I am saying, Kevin? Yes. Now to that, we take one example. Take the example of what? CH2 double bond CH2. We take the example of the ethene gas. Now to the ethene gas, adding of the what? Ozone gas at temperature of what? Minus 70 degrees. Because ozone gas is unstable at room temperature. That's why you can use temperature of what? Minus 70. Now the ozone gas attack on the pi bond. As ozone gas attack on the pi bond, you get what? You get an ozonoid is forming. Tell me what I am saying, students. You get what? Ozonoid is forming like that. Now you get an ozonoid like this. Clear what I am saying? And you get ethylene ozonoid. Tell me what I am saying? Ethylene ozonoid is forming. Simple explanation, no confusion of the explanation. And take the one more example of the acetylene gas. Say for example, acetylene gas will react with what? Acetylene gas is react with ozone gas. Again the temperature we take minus 7 because ozone is unstable at room temperature. So ozone gas is taken at temperature of minus 70. Now the ozone gas taken at temperature of the minus 70 and you get what? You get acetylene ozonoid. Yes, what is the carbon valency? The carbon valency is 4 and you get acetylene ozonoid. Is also called what? Ethine ozonoid is forming. Tell me what is forming? Ethine ozonoid molecule is forming like that. Simple explanation, no confusion of the explanation. Clear? So get ethine ozonoid molecule is forming. Understood? Yes. Neat explanation, no confusion of the explanation, right? And take the next question. So simple logic. Ozone gas react with what? React with the unsaturated hydrocarbons of the alkenes and alkynes. Now the ozone gas itself is unstable at room temperature. That's why the ozone gas is handled at minus 70 and that ozone gas attack on the pi bonds and you get ethine ozonoid molecule. Now see next one. Give two examples each for position and functional isomerism. Now first we go for the concept of what? First we go for the concept of the positional isomerism. Now regarding the concept of the positional isomerism, first of all, so what is the isomerism? The isomers, see, the isomers with the same molecular formula. The isomers with the similar molecular formula. Tell me what I am saying? The isomers with the similar molecular formula differ in the position of the functional group. What I am saying? Differ in the position of what? Differ in the position of what? Differ in the position of the functional group. That is the meaning of what? Positional isomers. With the concept once again. The isomers with same similar molecular formula differ in the position of what? Functional groups. That is the meaning of the positional isomers. Yes. We take the one example for that. Take the simple example CH3, CH2, OH. This is called ethyl alcohol, right? Right. CH3, CH2, CH. This is called IUPAC name propane 1R. Right, student? So the same molecule I am written like this: CH3, CH, OH, CH3. You get what? 2 propanol. That means the position of the function group what happens? Position of the function group changes. Here the function group alcohol attached to the first carbon. Here the alcohol is attached to what carbon? Second carbon. That's the difference of the position of the function group. Simple logic, no confusion. You take the one more example. CH3CO, CH2, CH2, CH3. Its name is called 2-pentanone. Pentane plus 1 is called 2-pentanone. Now the same molecule I am writing like CH3, CH2, CO. What you write? CH2, CH. This is called what, students? This is called 3-pentanone. Now here the position of the CO group is what? The position of the CO group on the second carbon. Here the position of the CO group on the third carbon. That means the position of the CO group is varying. The position of the CO group varying means what? Examples of the positional isomers. And take this example of the functional group isomers. Now regarding the concept of the functional group isomers, so what we write? Regarding the concept of functional group isomerism, first you write the statement. For 2 marks question, the statement is very important. 2 marks plus 2 marks, you have the 4 marks. Now regarding the functional group isomerism. So what the meaning of the functional group isomerism? Simple explanation, no confusion. The isomers with the similar molecular formula, the isomers with the similar molecular formula differ in the functional group. What I am saying? Differ in the what, students? Differ in the functional group. That is the meaning of what? Functional group isomerism. Tell me what I am saying. That's the meaning of what, students? Functional group isomerism. Clear what I am saying? Take the one example better to understood. Take the example of CH3, CH2, OH, ethyl alcohol. To this ethyl alcohol you write as what? CH3O, CH. Now this is ethyl alcohol. Its name is called what? Ethane plus all is called ethanol. So this is called what? Dimethyl ether. Tell me what you write? Dimethyl ether, like that. Simple explanation. We take the one more example for that. So the one more example to that is what? CH3, CH2, C double bond OH, aldehyde. It is called propanol. What you write? Propanol. To the same propanol, what you write? CH3, CO, CH3, you get propanone. Aldehyde, common ketone are examples of what? Functional group isomers. Here the functional group is what? The functional group is here aldehyde. Here what is the functional group here? The functional group is ketone. Different the position of the different their functional groups. Here the functional group is what? The functional group is alcohol. Here the functional group is what? Ether. That's the difference of the functional group isomerism. Simple logic, Nana, no confusion. So isomers with what? Similar molecular formula, different their functional group. Alcohol is the functional isomer of what, Nana? Ether. O linkage is called ether. Aldehyde is the functional isomer of what, Nana? Ketone. Aldehyde is the what? Functional isomer of what, Nana? Ketone. Understood what I am saying? Yes. And good, next one. So what do you understood about geometrical isomerism? Simple logic. See, first of all you write the statement. If you have the statement, better to write the statement to make more impression of the examiner. So geometrical isomerism means what? Geometrical isomerism means, so difference observed at attachment of two different functional groups, or you just write as two different functional groups which are present on doubly bonded carbon. Present on what carbon? Doubly bonded carbons. Present on doubly bonded carbons. That is the meaning of what? Geometrical isomerism. Repeat the statement once again, students. What I am saying? Difference observed. Tell me. Difference observed at attachment of what? Two different functional groups which are present on what? Which are present on doubly bonded carbons. Say for example, C double bond C. What you write? You write as methyl H. And again what you write here? Methyl H. Yes. So to this doubly bonded carbon, methyl H, two groups are different. To this doubly bonded carbon, methyl H are different. Now methyl on what side? Same side. So this is called cis-2-butene. What you write? Cis-2-butene. To the same thing, now I am writing trans-2-butene. So how you write the trans-2-butene? C double bond. See, I am writing methyl group here and H here. I am writing methyl group here and H here. Now this is called what? This is called trans-2-butene. How you write? This is the trans-2-butene. Here methyl group on the opposite side, na? because methyl metal on the opposite side you get trans 2. Here methyl metal on the same side, simple logic. Methyl metal on the same side, that is called cis form. So methyl metal on the opposite side, that is called what form? Trans form. Simple logic, no confusion in the logic. Clear what I am saying? Right. Now see the just one simple explanation. So explain indirect effect. This is very important. Mesomeric effect, resonance effect. So this is removed from the syllabus. For IPE syllabus, in the 30% syllabus, this part is there. Effects are not there, none. Effects are not there in the 30% of the IPE syllabus. Understood what I am saying? Yes. Next one. So this is very important. So what is very important? Explain the method of the EZ configurations of geometry lessons taking CHL as per your example. Yes. First of all, E means what, Nana? E means end giga. What is the meaning of end giga? End giga means what? Across the double bond. Tell me what I am saying. Across the double bond. Across the double bond means what? Across double bond means nothing but transform. Tell me what form, students? Transform. Simple logic. And Z means what? Z means Jusamen. Tell me what is Z? Z means Jusamen. Jusamen means what? Jusamen means what? Together. Together. Across the together present along the double bond. Together present along the what? Together present along the double bond. Together means what, Nana? Together is nothing but cis form. Tell me what form? Cis form. Understood what I am saying? Clear, Nana? Very good. Now take the example of this. Now regarding the example of this, you write like CH, Cl, and you write double bond CFPR. Actually, so we can follow the CIP rules. Tell me what rules are followed? CIP rules are followed. So what are CIP rules? Con, involved, Villard rules. So these con, involved, Villard rules, priority given on atomic number. Priority given on, priority embossed. The priority embossed means what? Given on atomic number of the group. Priority given on atomic number of the group. For example, is a hydrogen atom. Its atomic number is 1. Is a chlorine atom. Atomic number is what? 7. High priority, high atomic number, high priority. So here atomic number is what? Atomic number is 9. Here atomic number of the bromine is what? That is 35. So high atomic number, high priority. So that's why this is bromine, chlorine on the same side. That's why this is called Z form. Tell me what form? Z form. Simple explanation, no confusion of the explanation. Understood what I am saying? On the W1 carbon of the hydrogen comma chlorine, the high priority for chlorine is a high priority. Out of the F comma bromine, high atomic number is for bromine, that is what? 35. That's the high priority. So high priority groups are present together along double bond. So this is Z form. And you want the what form? E form. Simple as C double bond C. Just bromine writing upside, chlorine writing downside. And this is hydrogen and this is chlorine. Understood? Now here, the same logic you write. Now the priority goes toward bromine group. And the priority goes toward chlorine group. Now the bromine group and chlorine group both on what side? Opposite side. Because of the opposite side, you write as a what? You write as a E form. E form means what? Across the double bond. E form means what? Across double bond. It is a trans. Because out of chlorine comma bromine, high priority goes to the bromine. Out of the hydrogen comma chlorine, high priority goes to the what? Chlorine. That's why both are on opposite side. So opposite side means what? That is the E form. Understood what I am saying? Yes. Simple logic, no confusion in the logic. Clear? Yes. This is next one. Discuss Markovnikov rule, and next one is what? Karash effect. Simple explanation. How you explain the Markovnikov rule? Simple statement. You write like this. See, the Markovnikov's rule explained. The Markovnikov's rule explained as simple statement. In unsymmetrical alkene, tell my statement, student. In unsymmetrical alkene, the negative species of reagent, what I am said, the negative species of the reagent attacks on the doubly bonded carbon, double bonded double bonded carbon with less number of substitutions. What I am saying, less number of substitutions. Simple explanation, no confusion. With what, Nana? With less number of substitutions via carbocation as intermediate. What I am said, via carbocation as intermediate. Tell me my explanation. Via carbocation as intermediate. Repeat the explanation once again. See the concept. So what is Markovnikov rule? The Markovnikov rule explained as in unsymmetrical alkene. Tell me, student. In unsymmetrical alkene, the negative species of the reagent attacks on the doubly bonded carbon with less number of substitutions via carbocation as intermediate. Don't worry. Now I explain with one example you understood. Take the example of the unsymmetrical alkene, CH3CH, double bond CH2. This is an unsymmetrical alkene. To that, adding of HBr. What is HBr? Hydrobromic acid, H plus Br minus. Tell me, students, H plus Br minus, that is called what? Hydrobromic acid. Now here, one of the pi bond is shifted like this. When pi bond shifted like this, getting of negative charge and getting of positive charge. Now the negative species of the reagent attacks on the doubly bonded carbon with what? The negative species of reagent attacks on doubly bonded carbon with more number of substitutions, not less number, small correction, more number of substitutions. Brother, a small correction. Negative species of the reagent attacks on doubly bonded carbon with what? More number of the substitutions. Now, this doubly bonded carbon substitution has what? One methyl. This doubly bonded carbon has no substitutions. Simple hydrogen. Hydrogen atoms are not a substitutions. Methyl group is a substitution, understood? But hydrogen atoms are not substitution. That's why the negative species of the Br minus attack on C plus, H plus, and attack on the CH2 minus. Now what you get? You get CH3, CH, Br, CH3. Now you get 2-bromopropane. What is forming? 2-bromopropane is forming. This is called Markovnikov's rule. Simple explanation, no confusion of the explanation. See, repeat the point once again. The negative species of reagent attacks on the doubly bonded carbon with more number of the substitutions. The negative species, that is Br minus, attack on doubly bonded carbon with what? Attack on doubly bonded carbon with having what? The carbon having more number of substitutions. Br minus attack on the C plus, and H plus and attack on what? CH2 minus, and you get what? 2-bromopropane. Any doubt? You have it. And come to the Karash effect. The Karash effect is exactly opposite. So how you define the Karash effect? No. See, the Karash effect is also called what? The Karash effect is also called peroxide effect. Now regarding the Karash effect or peroxide effect. Karash effect is also called peroxide effect. That means what you write? In the presence of the peroxide, tell me, in the presence of what? In the presence of the peroxide. Take the example of another peroxide. You take benzoyl peroxide. Tell me, students, what you taken? Benzoyl peroxide is taken. Okay, this is called benzoyl peroxide. So in the presence of the benzoyl peroxide, tell me my explanation. What my explanation, students? In the presence of peroxide. So what is the peroxide is taken? Benzoyl peroxide is taken. So the bulky size of radical, what I am saying, the bulky size of radical, that is the bulky size of radical is what? Br dot. What is the bulky size of radical? Br dot attacks on the doubly bonded carbon. Attacks on doubly, D-O-U-B-L-E-Y, doubly bonded carbon with less number of substitutions. With what? With less number of substitutions. Attacks on the doubly bonded carbon with what? Doubly bonded carbon with less number of the substitutions via radical mechanism. Via what mechanism, students? Via radical mechanism. Understood what am I saying? So via radical mechanism, the reaction pass out. That is called what? Karash effect or peroxide effect. Repeat the statement once again, students. In the presence of the peroxide, the bulky side of the radical, that is Br dot, attacks on the doubly bonded carbon with what? Less number of the substitutions. Attacks on what? Doubly bonded carbon with the. So the bulky size of the radical Br dot attacks on the doubly bonded carbon with less number of substitutions via what mechanism? Via radical mechanism. Now take the one example. Take the example of what? CH3, CH, double bond CH2 is the propane gas. To this propane gas, adding of what? HBr, right? Bond breakdown like this. When bond breakdown like this, you get what? H dot, Br dot. Now, in the presence of the peroxide as catalyst, what I am saying, in the presence of the peroxide as catalyst on heating, now one of the pi bond is breakdown. What I am saying, one of the pi bond breakdown, and you get dot dot. Now the bulky size of the Br dot attack on doubly bonded carbon with what? Less number of substitutions. So H dot attack on the C dot. Now what you get, student? You get CH3, CH2, CH2, Br you got. That is called what? You get 1 bromopropane forming. Tell me what is forming, students? So 1 bromopropane is forming. With the simple logic, that is called what? Karash effect. Simple explanation, no confusion of this effect. Nana, very easy, Nana, no confusion or explanation, and you get 1 bromopropane. Simple logic, no confusion. Understood what I am saying? Yes, this is the one of the, you write the statement like this and you write the example. Example is highly reversed and you get the full marks. And you get what, Nana? Full marks, no confusion of that. And go for the next example. Now, so what is carcinogenicity? Explain with 2 examples. Simple explanation. So actually, carcinogenicity means most of the what? Most of the polynuclear, most of the polynuclear aromatic hydrocarbons. Tell me what I am saying. Most of the polynuclear aromatic hydrocarbons produces carcinogenic nature. Produces what nature? Carcinogenic nature on incomplete burning in air. Incomplete burning in air. Incomplete burning in air is the simple explanation. Repeat explanation, students. What I am saying, students, carcinogenicity. So what is the meaning of the carcinogenicity? Carcinogenicity means most of the polynuclear hydrocarbons produces carcinogenic nature on incomplete burning in the air. Best example, cigarette smoke. The cigarette is composed of 1000 polynuclear aromatic hydrocarbons, and incomplete burning gives what? Cigarette smoke composed of the nearly 1000 carcinogenic chemicals because of incomplete burning of the smoke in the air. Understood? Yes, Nana. So what are the examples of this one? So one of the best example of this one is phenanthrene. So this is the one of the best example of the carcinogenic molecule is what? Phenanthrene, like that. So one of the other example of this carcinogenic molecule is what? Anthracene. So these are the examples of carcinogenic molecule. Benzene also example of what? Carcinogenic molecules. Simple logic. Brother Narendra, already the preparation of acetylene is explained in the previous class. Nana. You subscribe to Roots Academy in the last class. The yesterday class, so I discussed about preparation of acetylene Narendra. Check the last class, Nana. You understood there. Calcium carbide anhydrous acetylene gas. And one more example. Tetrabromoethane heat with alcoholic zinc dust forms acetylene gas. Simple explanation, no confusion of the explanation, right? And see the next one. Yes, Juma's method, Jalda's method not there. This is removed in the 30% of syllabus, so this is not there. And see next one. So this is there. What is polymerization reaction? Explain with an example. Simple logic. First of all, what is the definition of? If any definition is there, better to write the definition perfectly understood. Polymerization means, simple explanation. Polymerization means the phenomenon in which, tell me what I am saying, the phenomenon in which the formation of a giant macromolecule. What am I saying? Formation of a giant macromolecule by combination of simple molecules. What I am saying? By combination of simple molecules are called monomers. By combination of simple molecules are called what? Monomers. That means monomers are combined themselves and forms a giant molecule is called polymer. That phenomena is called what? That phenomena is called polymerization. Repeat the statement once again, students. So what is polymerization? Polymerization means, simple as the phenomena in which the formation of what? The formation of a giant molecule by combination of the simple molecules are called monomers. So one of the best example. You take the example of acetylene gas. So N molecules of acetylene gas is combined. You know what I am saying? N molecules of acetylene gas is combined under high pressure with O2 gas. Under what? High pressure as catalyst of the O2 gas catalyst is used, and you get what? And you get polythene. Tell me what you get, students? And you form say polythene. What you get polythene? You get like CH, H like this. And you get a polythene forming. So this is called polythene. One of the best example. Understood what I am saying? And take the example of one more example you take. Take the example of the vinyl chloride. What I am saying? N molecules of the vinyl chloride combined, and you get what? And you get polyvinyl chloride. What you got, students? Polyvinyl chloride is formed. Because here vinyl chloride is a monomer now. Vinyl chloride is a what now? Monomer. That vinyl chloride combine themselves and forms a PVC. What is PVC? Polyvinyl chloride, plastic pipes. And see the next example. Describe any 2 minutes of preparation of the ethane. Yeah, a simple explanation. First explanation towards the preparation of the ethane. Take the example CH3, CH2, Cl to the adding of what? Zinc dust dissolved in the dilute HCl and gives what? And gives 2 nascent hydrogen atoms. Understood what I am saying? Zinc dust dissolved in what? Dilute HCl. Just on heating, what I am saying? Just on heating, and you get what? 2 nascent hydrogen atoms. One of the nascent hydrogen atom combines with what? This chlorine atom. Removed in the form of the HCl, and you get what? And you get ethane gas. Tell me what is forming? Ethane gas. Simple explanation, no confusion of the explanation. Clear, Nana? And take the one more example. So by which reaction we can prepare? By what reaction, Nana? By which reaction we can prepare the ethane gas? How? By using which reaction? You take the example of the butyl chloride. React with 2 moles of the sodium metal In the presence of solvent of what? In the presence of the solvent by ether. Tell me what is the solvent is using? So dry ether solvent is using 2 moles of the methyl chloride. In the presence of the dry ether solvent by using sodium metal, now what happens? So the sodium react with what? The sodium is reacting with this chlorine. Tell me, Nana. The sodium is react with what? This chlorine atom removed in the form of what? Removed in the form of the NaCl, removed in the form of NaCl, and we get what? Ethane gas is forming. Simple explanation. Tell me what gas is forming? Ethane gas is forming. Clear what I am saying? So this is the preparation methods of what? Ethane. So the first preparation method is what? Ethyl chloride heat with what? Zinc dust in the presence of HCl. Yes, and you get what? 2 nasal hydrogen atoms. One of nasal hydrogen atom combines with this chlorine atom removed in the form of what? HCl. And you get ethane gas is liberated. And by which reaction? 2 moles of the methyl chloride heat with what? Sodium metal. Under the ether, loss of NaCl, what happens? Ethane gas is liberated. Simple explanation, students. And go to the next one. This time any 2 minutes of preparation of what? This time any 2 minutes of preparation of the ethane. So now the some questions are completed. Now I discuss about some more important questions from this concept. So I discuss all the questions from the organic chemistry and I discuss about some more questions. See the some more questions I am explaining from this organic chemistry. For example, in organic chemistry the conversions are very important. In the examination, now some conversions are given like this and tell me your answer. How the question is given now? The question given like this. Calcium carbide solid. So on heat with what? Water. Gives rise to what? A. So A is subjected to what? A is subjected to heat with what? Ozone gas. Right? And step B, we can use zinc dust in the presence of the water. Use B. Okay, what are A and B? The question given like that, Narendra. Sometimes in the examination of organic chemistry, so simple conversions are given. What are given, Nana? Simple conversions are given. Calcium carbide. Yes. Calcium carbide means what? Ca plus 2, C minus, triple bond, C minus. Now this is plus 2 and this is what? Minus. Now heat with water. What is water? H plus OH minus. Water means what? H plus OH minus. Now Ca plus 2 combines with OH minus. Now loss of the calcium hydroxide is the one of the method of preparation of what? Acetylene gas. Removal of the calcium hydroxide aqueous solution. A is forms what? Now the A is what? A is acetylene gas is formed. Understood acetylene gas formation? So this is the acetylene gas. Now send out the what? Send out the ozone gas. Now when ozone gas is passing and you first step, what happens? The ozone gas attack on the CH, it will want CH and you get CHO, CH and you get O. Understood? And carbon valence is 4, you get ozonoid. So this is called ethyl ozonoid is forming. Now to this ethyl ozonoid, adding of what? Zinc dust in the presence of water. Simple explanation. Now the bond is cut off here. What I am saying? The bond is cut off here. This oxygen and this H2O. This oxygen and this H2O removed in the form of H2O2. Understood, Nana? And you get what? And you got glyazole. What you got, student? And you got glyazole. Simple explanation arranged. Simple. CH double bond O and make a single bond. CH double bond O, you get glyazole. Now what is glyazole? Ethane 1,2 diol. Glyazole is a common name and IUPAC name is what? IUPAC name is ethane 1,2 diol. IUPAC name is what, Nana? Ethane 1,2 diol, that is the answer. So A is acetylene gas and B is glyazole. I understood what I am saying, Nana? Narendra, is clear, Nana? As you ask, method of preparation of acetylene is the one of the method of preparation of acetylene. Calcium carbide solid dissolved in the water on heating by liberation of acetylene gas is absorbed by removal of the calcium hydroxide aqueous solution. Understood what I am saying? Now send out the ozone gas in step 1 and step 2. Zinc dust in the presence of the water and removal in the form of this oxygen and this H2O. They put in the form of H2O2 and you get the dihexyl. So the dihexyl is what? Ethane 1,2-diol. Tell me the answer. Ethane 1,2-diol. Clear what I am saying? And see the next question. But these conversions are very important for IPE 2 marks questions. Right, Nana? Take the one reaction. Say for example, a question given like this. So, acetylene gas passing into what? Acetylene gas is passing through red hot iron tube. What I am saying? Red hot. Acetylene gas is passing through red hot iron tube or copper tube. Red hot iron tube gives A, right? And through this A subjected to concentrated nitric acid plus concentrated sulfuric acid. The temperature is taken below 60. What I am saying? Temperature is taken below 60 gives B. What are A and B? The question given like that. Acetylene gas is passing through red hot copper tube gives A. A is subjected to what? Nitration mixture. Temperature is what? Below 60. Temperature below 60 gives you get B. So what are A and B are formed? Yes. Simple explanation. So 3 moles of the acetylene gas. 3 moles of acetylene gas is passing through red hot iron tube and you got a benzene. Understood what I am saying? And comes a benzene. Now to this benzene, heat with what? Nitration mixture. So what is nitration mixture? Nitration mixture on heating temperature below 60 you get NO2 plus OH minus. Understood? Now in the benzene, one of the hydrogen removed as what? So one of the hydrogen removed as a H plus, right? Now this H plus combines with what? OH minus. Loss of what? Loss of H2O. Now that NO2 plus. Tell me what I am saying. Now NO2 plus. What is NO2 plus? So nitronium ion attack on the benzene with what? Benzene with the sigma bond and you get nitrobenzene. Tell me what you got? You get nitrobenzene formation is observed. Simple explanation, no confusion of the explanation. Understood, Nana? The NO2 plus attack on the benzene with sigma bond. Yeah, sigma bond means what charge? Negative charge. The NO2 plus is electrophile. Tell me, NO2 plus is what? Electrophile. The electrophile or the NO2 plus attack on the benzene with sigma bond and you get nitrobenzene. Easy explanation, Nana. No confusion of the explanation. Right? This is one of the important 2 marks question. Now these 2 marks questions are given like this. Understood what I am saying? Now, one more 2 marks question given like this. What is elimination reaction? What is elimination? All is the previous question, Anna. Anna, I write all the previous questions is there in my cell phone. Okay? Yes. What is elimination reaction? Give one example. Give one example to the elimination reaction. Simple explanation. So what is elimination reaction? Says removal of the groups. Simple explanation I am writing. Elimination reaction means removal of the some groups from the molecule. Removal of the some groups. Tell me what I am saying. Removal of the some groups from the molecule. Removal of the subgroups from the molecule in the presence of reagent. What I am saying? In the presence of what? In the presence of reagent forms unsaturated molecule. Forms what molecule? Unsaturated molecule. That is the statement. Repeat the statement once again. What is my statement, Nana? Elimination reaction means removal of what? Removal of the subgroups in the molecule in the presence of the reagent forms a what? Unsaturated molecule. That is the meaning of what? That is the meaning of elimination reaction. Understood, Nana? Repeat once again. Elimination reaction means what? Removal of the subgroups in the molecule in the presence of the reagent forms what? Unsaturated molecule. You take the example of one that, take the example, say for example, CH2Br single bond CH2 Br. Heat with what? Heat with alcoholic zinc dust. Now zinc is what? Zinc valence is plus 2 now? Yeah. Zinc valence is plus 2. That's why Zn plus 2 combines with what? Br minus loss of what? Loss of Zn Br2 and forms what? And forms CH2 double bond CH2. Ethene gas is liberated. Simple explanation. No confusion of explanation. Understood? And take the one more example. CH Br Br and CH Br Br, because bromine is bulky size now. Adding of what? Adding of the 2 moles of alcoholic zinc dust. Adding of what, Nana? 2 moles of the alkali zinc dust. Zinc valence is what? Plus 2. That's the loss of what? 2 moles of ZnBr2, and you get what? And you get acetylene gas is liberated. Then what liberated? Acetylene gas is liberated like that. Simple explanation, no confusion of the explanation. Understood? Like that. Take the one more example. Dehydration of what? Dehydration of ethyl alcohol. Is ethyl alcohol subjected to dehydration? Heating with what? Concentrated H2SO4 at temperature of what? 170 degrees. Heat with the concentrated H2SO4 at temperature of 170. So removal of the water observed. Tell me what is observed? Removal of the water. Now here H plus, here OH minus. Now loss of the water. Now loss of the water, and what you get? CH2 double bond, CH2 you got, and you got ethene gas. Tell me what gas is forming? Ethene gas is forming. Examples of elimination reactions given like this. Understood what I am saying, Nana? Easy explanation, no confusion. Just refer to the example. So these are the important organic chemistry questions. Understood what I am saying? Yes. Okay. And write one more question. These are very important for 4 marks question. These are very important for 4 marks question. Write that question. So define metamerism. Define metamerism. Define metamerism. Write with example. Define metamerism, write with example. Definition carries 2 marks, example carries 2 marks. Repeat the question once again, Nana. Define metamerism, write with example. First you write the statement. So how do you define the metamerism? Simple explanation. See, metamerism defined as, see the statement, metamerism defined as the isomers with similar functional group. What I am saying? The isomer with the similar functional group, but differ in the number of carbons, of alkyl group arrangement. Or arrangement, student? Alkyl group arrangement. That is known as metamerism. The isomers are called metamers. Repeat the statement once again. So what is metamerism, Nana? So metamerism is defined as the isomers with what? The isomers with the similar functional group. The isomers with what, Nana? Similar functional group, but differ in the number of carbons of what? Different the number of carbons of the alkyl group arrangement. What I am saying? Different number of carbons of what, Nana? Alkyl group arrangement. That is the meaning of what? Is metamers. That phenomena is known as what? Metamerism. But take the one example for that. CH3, CH2O, CH2, CH3. This is called diethyl ether, right? So that same diethyl ether you write like this. How you write? CH3O, CH2, CH2, CH3. Now this is called methyl propyl ether. Tell me what you write? Methyl propyl ether. Yes. Here function group is same. So what is the function group here? The oxygen is a function group here. Here the oxygen is a function group. Differ happens in number of carbons. Here how many carbons are there? 2 carbons. Here 1 carbon is there. Here 2 carbons are there. Here 3 carbons are there. Different number of carbons of alkyl groups like that. Understood what I am saying, Nana? I think Nana, simple explanation, no logic, Nana. Function group is same. Here increase the function group, here increase the function group. But difference happens in what? Number of carbons in alkyl. Here 2 carbons are there, but here only 1 carbon is there. Here 2 carbons are there, here 3 carbons are there. And take the one more example to that. Take the example of this CH3, CO, CH2, CH2, CH3. This is called 2-pentanone. Tell me, 2-pentanone. The same 2-pentanone, how do you write? CH3, CH2, CO, CH2, CH3. This is called what? This is called 3-pentanone. What you write, Nana? 3-pentanone. Now here you write as a 2-pentanone. Here you write as what? 3-pentanone. Now, simple logic. Here what is common? Here the function group is what? The function group is ketone. Here what is common? Function group is ketone. Understood, Nana? The function group is same, but differ happens in number of carbons. Brother, it's very easy, brother. Understood what I am saying? Narendra, respond. Narendra and Kevin creation. Only the 2 members we are seeing now today class, because most of the students are getting tired from morning onwards. You are studying the morning onwards. You are studying mathematics, biology, botany, and physics and chemistry. That's why you are tired. Only 2 members come now are public online. Right now, Narendra, very good. So function group is same. Now here number of carbons are what? 1 carbon. Here how many carbons are there? 2 carbons. Here 3 carbons are there. Here 2 carbons. Difference happens in number of carbons after alkyl. That is the meaning of what? Metamers. Simple explanation. No confusion of the explanation. Right? What I am saying is clear? Yes, Nana. It's very easy. Now, this is one of the important question. Now write the one more 4 marks question. Now today the organic chemistry completed, and tomorrow we go for the remaining topic, that is we go for the thermodynamics topic. What topic? What is the group according to the blueprint? Which topic is there? Now tomorrow we explain that topic. Understood, Nana? Yes, Nana. Yes. Now one question is given like this. Define. Yes, Nana. So define optical isomerism. Define optical isomerism. Explain with one example. Maybe given for 4 marks. Explain with one example. Define optical isomerism. Explain with one example. Now, how you define optical isomerism? The non-superimposable, what I am saying, the non-super, repeat the point once again, the non-superimposable, the non-superimposable mirror images of what I am saying, the non-superimposable mirror images of chiral molecule. Tell me my statement. Non-superimposable mirror images of what molecule? Chiral molecule. What is the meaning of the chiral? Chiral means what? The molecule with absence of the elements of symmetry. The non-superimposable mirror images of the chiral molecule shows optical activity property. Shows what property? Optical activity property known as optical activity property known as optical isomerism. Known as optical isomerism. So take the one example of the optical active isomers. For example, we take the example aldehyde. Okay, CHOH, CH2OH, right? Again, what you write? CHOH, CHO, CH2OH. For example, is a D form of the glyceraldehyde. What form? D form of the glyceraldehyde. Definitely it is a L form of what? L form of the glyceraldehyde. No doubt. So, how you confirm? Here the OH group on the right hand side, the same OH group on the left hand side. What is the meaning of non-superimposable mirror image? The non-superimposable mirror images means what? The non-superimposable mirror images means the right appear like a left or left appear like a right. That is the meaning of what? Non-superimposable mirror images. Understood what I am saying? This is your complete explanation of what, Nana? Complete explanation of the organic chemistry. Now tell me, regarding this organic chemistry, have any doubts? Arey Nana, very easy, Nana. IPE question is very easy. Yeah, Nana. Narendra, what you are asking? Sodium propionate heat with the soda. Best, very good, Nana. You take the example of the sodium propionate. CH3CH2 COO-Na is what, Nana? Sodium propionate. Heat with soda lime. What is soda lime come to? NaOH plus CaO is the soda lime. Heat with the soda lime. Simple logic here. The CO2 gas is removed in the form of what? The CO2 gas is removed in the form of Na2CO3. Tell me what I am saying? The CO2 gas is removed in the form of what? Na2CO3. Now H atom attack on the CH2. Simple logic. Understood what I am saying, Nana? So here, this is a sodium propionate, Nana. Bangaram. Is a what? Sodium propionate. Now this sodium propionate heat with what? Soda lime. What is soda lime? NaOH plus Cl. Now the CO2 gas is removed. The CO2 gas is removed in the form of what? The CO2 gas is removed in the form of the Na2CO3 solid. Now this H atom attack on CH2 group and you get what? CH3 single bond CH3 and ethane gas is liberated. And what gas liberated? Ethane gas is liberated. Simple explanation, no confusion of the explanation. Understood what I am saying, Nana? Yes, ethane gas is liberated. That is called what? Sodium propionate heat with what? Soda lime. Understood, Narendra? Clear, Nana? Answer is happy? With that answer you are happy, Narendra? Yes, Nana. Thank you very much. Yes, this is your today's class.